Welcome back to Tutorials. In this mini-series, we're going to be looking at programming as a whole and the different elements that make up it. And we're also going to be looking at the way you should think to solve any sort of programming problem you may have. Now, in this video in particular, we're going to be looking at the three programming constructs, and these are the ideas that actually make up programming as a whole. So, why know about all this stuff that I'm going to cover in the mini-series? Well, sometimes you're going to have to use programming languages that you've never seen before, and you don't always have the comfort of spending time in lectures and watching videos to use them. So we need a way to program with any language with relative ease. Well, luckily for us, programming is actually more about problem solving and the way you think about things rather than the actual code itself. And being able to think computationally lets you pick up an unfamiliar language and just have the syntax of the language as the only thing you really need to learn, which is generally the easiest bit. Okay, I've got a quick example here of just two totally different languages, but we're solving exactly the same problem. We're trying to do exactly the same task. And what that task is we're trying to get the program to type a number, then it's going to take our input, so it's going to let us type a number in, and then it's going to print that number out. So it's going to output that number on the screen. So the first one we have is Python above, where we have the line print type a number. So that's just going to output to the screen the words type a number. Then it's taking our input and it's saving it in a thing called number. So it's just saving it in a thing called number that we can use later in the program. And then it's going to print to the screen, so it's going to output to the screen your number is, and then it's going to output the number that you typed in. Okay. Now below we have C++. And there's not really any major difference here, apart from the words you have to use and the terms you have to use to get the same result. Now, there is one difference, is that instead of just saying number is our input, we're first actually going to define the fact that there is a number there first. So we need to tell the computer that we're going to have a number somewhere. So we're just defining an integer. We're going to call it x, so our number is being stored in x this time. And this time, instead of using the print command, we're using cout. So it does exactly the same job, it just has different words. We're then using cin instead of input to take our input. So it's going to cin and it's going to save it in that number x. And then we're going to use cout to output your number is, and then output x, so the number that you typed in. Now, you'll see that this code does exactly the same thing, and if you look at it really, there's not actually that much you have to learn to get the thing. You just have to learn what cout is and the fact that you need to define an integer. Okay, now we're going to look at the first programming construct, and this is probably the most important one. Well, let's say you were making lasagna. There's a series of steps that you're going to have to follow to make that lasagna. You're going to have to cook the mince first, then you're going to have to add the tomatoes and the other ingredients to the mince in the pan. Then you're going to have to bring it to the boil, and then once it's finished cooking, you're going to layer the mince, white sauce, and pasta in your tray, and then you're going to cook that all in the oven. So we've just got a list of instructions here, basically. But what if we were to change around the order of them? What if we were to layer the mince, white sauce, and pasta, and then cook it, and then bring it to the boil, and then add the tomatoes and ingredients, and then cook the mince? Well, that doesn't make any sense at all, and that wouldn't work if you were making lasagna. So that's why we have to have this thing called sequencing. Now, it's the most important programming construct, and all it does is essentially tell the computer which order to write the to run the instructions that you've written. Or in more technical terms, it tells the CPU which memory address to jump to. You can think about memory as a housing estate, and each memory address a different house in the housing estate. The sequence essentially tells the CPU which house to visit in what order. Imagine the instructions are stored in each house. Now, here I've got what those instructions might look like in code. So I'm just using Python as the example here. You don't need to understand the syntax here. Just what we're actually doing is we've got a few functions. We've got cook mince function. We've got an add ingredients function. We've got a boil function. We've got a layer function, and we've got a cook function. Now, in any sort of programming language, the computer is going to run those instructions in the order you've written them, from top to bottom. So cook mince, add ingredients, then boil, then layer, then cook. And that's good. It's not going to do what we did in the previous slide, where it's just going to jump about random instructions and it's not going to make any sense. Okay, now we come to the next programming construct. What if you are adding your layers to your dish? So you have to add mince, and then you have to add pasta, and then you've got to add sauce. And then if you've added enough layers, then you're going to cook it. And if not, then you're going to add another layer. You can add mince and pasta and sauce. And so we need a way of doing things like this in programming. We need a way of looping instructions until something's met, don't we? Now, this is called iteration. The computer iterates or loops over a certain set of tasks until a condition is met. Now, this could be, you could say, I want to loop over this set of instructions 3 times. So it's going to add mince, and it's going to add pasta, then it's going to add sauce 3 times. And then once that's happened, it's going to stop. But it could also be add mince and pasta and sauce until your dish is full. So it could be a condition like that as well. So when you're coding, any process that needs to be repeated and repeated again and again and again is going to use iteration. Okay, so this is what it might look like in code. Don't worry about the syntax here again, but essentially I've defined a function layer. So it's just something I'm going to run whenever I want to do the layer of my pasta. And it's taking an input. It's taking an input layer number, which is going to say how many layers I want in my lasagna. So let's say for instance, I'm going to say I want 3 layers in my lasagna. Then we've got the statement for I in range layer number. And all that means is it's going to loop over the code below. So add mince, add pasta, add sauce. It's going to loop over that code 3 times. So it's going to add pasta sauce, mince, pasta sauce, mince, pasta sauce, mince, pasta sauce, and then it's going to stop. You could also change the amount of layer numbers, and it would run that amount of times as well. Okay. Now, what if we were boiling our ingredients? So we're boiling the mince and the tomatoes and anything else you've added to it. Well, if it starts boiling over, you're going to have to turn the temperature of the hob down. If it's not bubbling at all and it just looks like it's almost cold, then you're going to have to turn the heat up. And if neither of those things are true, then you're just going to leave it the same to cook, aren't you? This is our final programming construct. It's called selection. It tells the computer which of your instructions to run depending on a certain condition. So we go back to the previous slide. The condition here is if it's boiling over, and it's true, then I'm going to turn the heat down. And if it's not bubbling at all, then I'm going to turn the heat up. It's sometimes known as branching. So the CPU will branch from one instruction to another. So like the house analogy I used earlier, it might get to a certain house, and that house will end up saying, instead of visiting the house next to me, I want you to visit the house on the other side of the housing estate. And the person is then going to go and visit the house on the other side of the housing estate. In this example, you also see that it keeps looping round and round, so as it happens, iteration is also needed. Selection and iteration come hand in hand a lot of the time. Iteration almost always uses selection. Now, I've got an example of what the code might look like here. So this time we've made a function boil, so to boil the stuff, and we're saying while cooked equals false. So while what we're boiling is not cooked, it's going to check. If it's boiling over, then it's going to run the temperature down function. It's going to turn the temperature down. Or elif, else if, or if is either way you think about it. If it's not boiling, then we're going to run the temp up function, and it's going to turn the temperature up. Or if everything's fine, else, if none of those things are true, then it's just going to continue, and it's going to loop round, and it's just going to keep checking and checking and checking. Any code you ever see can be broken up into instances of these 3 programming constructs. And it's really useful you know about them so that when you're trying to break down a problem into smaller bits and you're trying to solve it, you know whether you need to use instances of these constructs or not. Anyway, that's it for this video. In the next video, we're going to be looking at variables and modularity. Now, don't worry about the terms right now. I will be covering them in that video. Thanks for watching.